Okay, so we are doing the next lesson 32 out of your textbook, but again, it's not in your textbook, it's in these handouts. To get the handouts, if you weren't in school, then you can go to the assignment from Friday, and they're there. And just print the pages that we need, because there's more in there than I'm actually going to use. So today, you're going to use page 2 and 3 of the classwork section and page 21 and 22, I think, of the homework. All right, so the first thing is wherever you left off in your composition book from Friday, so that should be on the back of the pocket that you made to hold your handouts. We need to put this table, and it's just a good reference so that we don't have to use our calculator to evaluate logs or to solve those exponentials. We have the numbers that we're going to need here. All right, so pause the video, write this down, and then start it back up. All right, so section 3.2 is on logarithmic functions. So the first thing you need to know is that logs were created to find exponents. So if I have something like 2 to the x is equal to 8, so like we did yesterday, we can rewrite those with the same bases and figure out the answer. But if I have something like 2 to the x equals 6, I can't do that without a log. And we'll learn tomorrow how to handle the ones that we can't just figure out. For today, we're still just going to be basically doing the same thing we were yesterday. They're just going to give it to us in log form to start with. All right, so inverse of an exponential, that's another way of thinking of a log. They were created to find exponents. Logs are the inverse of an exponential. They are there so that you can figure out what exponents, missing exponents are that are hard to figure out otherwise, are impossible actually. So inverse meaning they undo. They're operations that undo each other, like addition and subtraction or squaring and square rooting. All right, the picture of a log function looks like this. So remember that an exponential looked like this. And if you'll remember inverses from algebra 2, you're going to reflect over the line y equals x. So if you take this graph and you reflect it, you get this graph. So for an exponential, you have an asymptote of the x-axis. So for a log, you're going to have an asymptote of the y-axis, which means your domain is now restricted. So logs, you have to plug in a positive number. You can't take log of 0. You can't take log of a negative. All right, a couple other things to remember is that there are 2 special logs, and they're the ones that your calculator actually has a specific button for. If we're going to do log base 10, that's called the common log, and we don't write the base. We just put log 10. If we do a natural log, log base e, e is the natural number, and we'll discuss what that is later in the video. Then actually we'll discuss it tomorrow because we didn't get to that in class today. But anyway, e is called the natural number, and we'll figure out what it is and where it came from and all of that good stuff in tomorrow's lesson. But for now, you just need to understand that it's kind of like pi. It's a symbol that represents a specific number, about 2.7. And if we have log base e, we write it as ln. It's just understood if you see ln of something that the base is an e. All right, so the handouts is where we're going next. All right, so page 2, we're going to talk about the bottom half of the page today. Let's see if I can get it all fit. There we go. All right, so at the beginning, it's the same things that I was just explaining. It's just telling you that solving exponential equations like we did yesterday are easy because you can make the bases the same. But if you have something that looks like this, we can't make the bases the same. So that's where logarithms came from. It's just the inverse of an exponential. All right, so then he makes a joke about kids being scared of them, blah, blah, blah. All right, so like these 2 things are equivalent statements because one is just the inverse of the other. If you took this and you tried to solve for x, you'd have to take the cube root of both sides, and that's where this equation comes from. So if I give you an exponential, you could rewrite it in log form, and those are equivalent expressions. So that's what's in this box. Log base b of y equals x is the same thing as b to the x equals y. And I have it written over here just as it's the way that it was taught to me. It helps me remember. if you think about the little loop circle pattern, the base stays the base, the answer becomes the exponent, the guts become the answer. So if I go from log to exponential, the base stays the base, the answer becomes the exponent, the guts become the answer. So just to practice that skill, if I asked you to write log base 2 of 8 equals 3 in exponential form, you would say the base is 2, the exponent is 3, the answer is 8. If I asked you to write log base square root, I don't know why I wrote square root, sorry. Log base 49 of 7 equals 1/2. Then in exponential form, you would have a base of 49 to the 1/2 power is equal to 7. All right, so when you're writing these, like if this was on lined paper, the line would be like right there. So that 2 is a subscript. So it's written smaller and down from everything else. But the rest of everything is all the same size and they're aligned together. Okay, so to evaluate logs, you can use your calculator. There are buttons to push, and that is part of tomorrow's lesson. How do you put logs in your calculator when they're not common log or natural log? Because those are the only ones there's actually buttons for. If you have the graphing calculator and the new operating system, there's a way to type it in exactly like it looks. If you're trying to use your phone, then you need something called the change of base formula. But again, that's a lesson for tomorrow. Today, we're just going to work with ones that you can figure out without your calculator. So if you think about it as equaling something, and you don't have to put a variable there, it's just easier for a lot of kids if they do. Like on the rest of them, I never put that. So I'm saying log base 2 of 8 is equal to what? Well, if I write it in exponential form, I'm saying 2 to some power gave me 8. So we know 2 to the third is 8, so the answer is 3. On this one, again, I'm going to kind of go through these quickly, but explain myself as I go, that you have a pause button, pause, rewind, whatever, so that you can stay caught up. All right, so we're going to say 3 to some power is 81. Well, we know 3 to the fourth is 81. And I say we know because hopefully most of these you do know, but if not, you have that chart to refer to if we get to kind of big numbers. All right, so the next one, we're saying 5 to some power is 1 over 25. Well, remember that 25 is 5 squared, and to make it not be a fraction, we give it a negative exponent. So we get negative 2 as the answer because 5 to the negative 2 is how I would get that 1 over 25. All right, number 12, you have 4 to some power is 32. Well, there's no way to do that. There's no exponent that magically does that, like a whole number anyway. So we can write them both as a base 2, like we did with yesterday's work, and solve that little equation that results when I set the exponents equal, and we get 5 halves is the exponent that we originally needed. All right, so if we have 8 to some power is the square root of 2, again, write them with the same base. So 8 is 2 to the third, square root of 2 is 2 to the 1/2, because an exponent of 1/2 means square root. I'm going to write that a little smaller so it looks more like an exponent. All right, so then we set our exponents equal, divide by 3 on both sides, and you get 1/6. All right, so here 25 to a power is the cube root of 5. Well, remember cube root, again, I can write as an exponent of 1/3. So then it's 2x equals 1/3, which gives me 1/6 when I divide by 2. All right, 15. 36 to some power is 1 over the square root of 6. So write those both with a base of 6. So 36 is 6 squared. The square root of 6 is 6 to the 1/2, but to move it to the numerator, I have to give it a negative exponent. So we can set the exponents equal and solve. For 16, you have 9 to some power is 1. Well, anything to the 0 is 1, so you get 0. All right, next page of your notes, so we're on page 3 of the classwork. All All right, if you're re-watching this and you were in second block today, I clearly stated this incorrectly. In my brain, it was 9 to what power is 1, and we said 0 was the answer. I think that's not true because it's saying 9 to what power is 0. And remember that the domain of a log has to be positive numbers. So you can't raise 9 to a power and get nothing. So that this one has no solution. The same thing with 18. You're trying to say 3 raised to a power, positive 3 raised to a power is going to give you negative 9, and that doesn't happen. But again, the domain of a log is positive numbers. I cannot take log of a 0, and I cannot take log of a negative. So that's always going to be no solution, or it does not exist, however you want to say it. All right, number 19. We are doing 5 times whatever this works out to be. So I did this work up here. I said 4 to what power is 8, and then I rewrote them both with the base of 2. Set the exponents equal and got 3 halves. So then 5 times 3 halves is 15 halves, or 7 1/2 if you want to change it to that. All right, the next one, we're saying we want to figure out what this is and square it. So the work for figuring this guy out is down here. So 9 to what power is 1/3? Well, 9 is 3 squared. Change 1/3 to 3 to the negative 1 because it was a fraction, make it not 1. Set your exponents equal, you get negative 1/2. So now we're doing negative 1/2 squared. If you do negative 1/2 times negative 1/2, you get positive 1/4 as your answer. All right, so we've already discussed this piece right here, and this is just telling you that if the base is 10, it's not going to be written, and it's called a common log. All right, so these last few right here should not be too difficult because everything is base 10, and most people are pretty good when we're talking about multiplying tens. All right, so it's the same thing that we've been doing. Rewrite it, figure out the exponent. So this one is saying 10 to what power is 100. So 10 squared is 100. 10 times 10 is 100. This one is 10 to what power is 1. So that's 0 because anything to the 0 is 1. Here we have 10 to what power is 1/10. So we get negative 1 because it was a fraction. To make it not a fraction, it would need a negative exponent. All right, this one we're going to figure out the answer and then square it. So to figure out the answer for this, we're going to say 10 to what power is 1 over 1,000. Well, 10 to the third is 1,000, so 10 to the negative 3 is 1 over 1,000. And so if you do negative 3 squared, you get positive 9. All right, over here, we want to figure this out and then times by 5. All right, so figuring that out over here, 10 to what power is the square root of 10? Remember, exponent for square root of the exponent for square root is 1/2, sorry. So 5 times 1/2 is 5 halves. All right, here, working down here, we're going to say 10 to what power is the cube root of 10. So cube root is an exponent of 1/3. So we're going to do negative 3 times 1/3 and get negative 1. All right, for these two, we are using the idea that if log means log base 10 of 10 to the 4th, if the base of the log and the base of this little piece match, then those are inverse operations. They literally just cancel, and that exponent is your answer. But if you don't remember that, you can always just write it like we've been doing. 10 to what power is 10 to the 4th? Well, 4. And the same thing here. 10 to what power is 10 to the square root of 5? The square root of 5. All right, so Euler's number, we'll discuss that in tomorrow's lesson because we didn't get to it in class today. When you do the homework problems, it will be there. So it's going to work out a lot like these. Remember that ln means that the base is e. So if I ask you to do ln of e to the second, then the 2, the little exponent, would just be the answer. All right, so you're going to do on the homework pages number 28 through 42. And the last 3 have an E, so just do the best you can with those 3, and tomorrow we'll actually learn that, and you can go back and change answers if you need to. All right, please let me know if you have any questions.